Here we are, the last video of Chapter 3, 3.5, Rational Functions, number 4. So instead of partnering up, because we can't necessarily do that, I'm going to have you guys try this one on your own. So you can kind of see a little sneak peek here. We're going to graph this function, okay? We can cross off our x minus 3, so that's going to lead us to a hole. So our cleaned up version is this guy here. So I want you to determine the holes, intercepts, asymptotes. Does it cross that horizontal asymptote? First, get all of the information, so pause the video and then come back before you graph it. All right, let's check your work. So we kind of already talked about how we had a hole. So remember, we crossed out x minus 3, so the x value of our hole was 3. When we plug 3 back into our cleaned up version, we get 147 over 10, or 14.7. We've got an x-intercept at negative 4, 0. It bounces. It's an even degree. We've got a y-intercept of 0, negative 24. Two vertical asymptotes, x equals negative 2 and x equals 1, coming from those factors from the denominator. Horizontal asymptote of y equals 3. The degree of the numerator matches the degree of our denominator, so we look at those leading coefficients. Does it cross that horizontal asymptote? Hopefully you got yes. Working through, you can kind of see my algebra here, verify it, make sure you understand it. Our domain is all real numbers except x can't equal 3 because we have a hole there, and x can't equal negative 2 or 1 because that's where our vertical asymptotes occur. So now that we have all of this information, go ahead and try to graph the function. Okay, so how did you do? All right, so make sure you plot all of the information. We've got a hole at 3, 14.7, so you're estimating that. All right, so that kind of indicates that this branch is up here, okay, stuck in that top right piece. We have a y-intercept. It's kind of off of my grid, but we get the idea. I know I don't have an x-intercept in here, so this branch is going to be stuck down here, which makes sense because along our vertical asymptote, we're in opposite directions. Over here, first, I know that along this vertical asymptote, our graphs need to be in opposite directions as well. So since this guy is down, I know on this side I'm going to be up. So I start up here. We know it crosses our horizontal asymptote at negative 18/7, 3. We're going to come to our x-intercept where we're going to bounce, and then we come back and follow our horizontal asymptote underneath. So hopefully you did okay, and we can check and answer any questions in class. This next example, we're going to work backwards. We're going to find the equation of the rational function from its graph. So what I want you to look at is I want you to identify if there's any holes, any intercepts, look at asymptotes, and see how that plays a role in the equation themselves. So let's take a look at the graph right now. So here's our graph. We're going to say that this value right here is a hole. So look at the x value of that hole. How does that play a role in our equation? Look at our x-intercepts. We've got an x-intercept here, and we have another one here. Look at the branches and our vertical asymptotes. And look how the branches are in opposite directions of one another along those asymptotes. How does that play a role in our equation? Okay. Look at our horizontal asymptote. It's not at y equals 0, so how does that play a role in our equation? So I'm going to walk you through this first one and kind of help you figure out how I came up with our equation. And then you're going to try the next one on your own. So, as I mentioned, we have a hole when x equals 1. Well, when we have a hole, that means we have factors that cancel, meaning I have a factor in my numerator and in my denominator. So if I have a hole at x equals 1, what's the factor that comes from? X minus 1. So I need an x minus 1 in both my numerator and my denominator. X-intercepts. I have an x-intercept at 7, 0, and it crosses there. I also have an x-intercept at negative 2, 0, and it crosses there. How does that play a role? Well, remember the x-intercepts come from our numerator. So if 7 is a 0, then x minus 7 is our factor. If negative 2 is a 0, then x plus 2 is our factor. Since they cross at both of those, I know my degree for each of those has to be odd, so I just kept it as 1. We have a vertical asymptote at x equals 3 and x equals negative 5, and the branches are both in opposite directions. Well, where do we get our vertical asymptotes from? Our denominators. So if x equals 3 is the vertical asymptote, what factor did we get that from? X minus 3. And if negative 5, x equals negative 5 is the vertical asymptote, what factor did we get that from? X plus 5. Since the branches are in opposite direction, that means our degrees of each of these have to be odd, so I just kept them as 1. The last thing, we have to take note of the horizontal asymptote, which is y equals 2. Since it's y equals 2, that means the degrees of our numerator must be the same. And you can verify we have a degree 3 over a degree 3. So then we have to put the leading coefficient. Well, since y equals 2 is the horizontal, that means 2 has to be a leading coefficient of our numerator, and we could leave 1 as the leading coefficient of our denominator. So here is the equation in factored form of this rational function. This is a possible equation. We could get more precise, but this is as good as we need for now. Now it's your turn. I want you to take a look at this graph, identify all of the key pieces. So here's a hole, okay? This point is an x-intercept and it bounces off of that point, okay? So kind of keep that in mind as you observe the graph and take note of all of the important information, and then see if you can come up with the equation yourself. Give it a try, come back and check. So here's what I got. I noted we have a hole at x equals negative 4, so that takes into account our x plus 4s in the numerator and the denominator. We have one x-intercept at 1, 0, and it bounces, so that takes into account the x minus 1 in our numerator, but since it bounces, I need an even degree there. So do you have that? We've got 2 vertical asymptotes. One vertical asymptote, the branches are going in opposite directions. The other, they're going in the same direction. So at x equals negative 3, I get the factor of x plus 3 in my denominator, and it's got to have an odd power, so I just left it as 1. At x equals 3, since the branches go in the same direction over here, I need an even power for this x minus 3 factor, so verify that you have that. Finally, I have this horizontal asymptote at y equals 0, so that means I have a higher degree in my denominator than I do in my numerator, which holds true, so I don't have to worry about any leading coefficient or make any change there. So how'd you do? If you can answer all of these pieces, then you know your rational function information pretty well. If you have questions, by all means, come to class and we'll discuss those next time.